Questions 1 through 10 of the 2000 Grade 12 AMC 12. In the year 2001, the United States will host the International Mathematical Olympiad. Let I, M, and O be distinct positive integers such that the product I times M times O is equal to 2001. What is the largest possible value of the sum I plus M plus O? So 2001, we have to factor it out because we want to make it the product of three integers. So 2001 is divisible by 667. And if you multiply 667 times 3, it'll give you 2001. But unfortunately, that's only 2. So what do we do here? We've got two scenarios. We can either break down the 667 into 23 times 29 and then keep the 3, or we can add a 1 right there. Both of these will equal 2001, correct? But we have to figure out the largest possible value of the sum I plus M plus O. Alright, so for the first one, what do we have for that sum? We'll have 667 plus 3 plus 1, which is 671. And the sum for the second scenario is 23 plus 29 plus 3, which is 55. So obviously this one is the largest. So the answer is E. 2000 times 2000 to the exponent 2000. So we've got 2000 times 2000 to the exponent 2000, like that. Well, this 2000 right here, we can just write it as exponent 1. And therefore, we've got 2000 to the exponent 1 times 2000 to the exponent 2000. And then since the bases are the same, you keep the base and you just add the exponents. So it would become 1 plus 2000, like that. And therefore that just becomes 2000 to the exponent 2001. And that would be answer A. Each day Jenny ate 20% of the jelly beans that were in her jar at the beginning of that day. At the end of the second day, 32 remained. How many jelly beans were in the jar originally? Okay, so originally there's a certain number of jelly beans, so let's just call that X. At the end of day 1, she has eaten 20%. So there would be 0.8x remaining, right? 20% are gone, so this is what's remaining. And then at the end of the second day, we have what? Do we have 0.6? No, that would be wrong. You can't do that. Tempting, but incorrect. You have to multiply 0.8 times what you have up here. So it's like this. Like that. This is correct mathematically. And they've told you that this is equal to 32 at the end of the second day. All right, so we'll just solve for that. So 0.8 times 0.8x is equal to 32. So this becomes 0.64. X is equal to 32. And therefore x is equal to 32 over 0.64. And that would equal 50. So the answer here is B. The Fibonacci sequence, as shown, starts with two ones, and each term afterwards is the sum of its two predecessors. Which one of the 10 digits is the last to appear in the units position of a number in the Fibonacci sequence? So let's write out this sequence, and first let's explain what's going on. So you have the first two are ones, and then to get to the third, you have to add the sum of the two preceding numbers. So 1 plus 1 is 2. That's how you get the 2. To get to 3, you have to add the previous two terms. So 1 plus 2 is 3. That's why we wrote 3. 5 is the sum of the previous two terms. 2 plus 3 is 5. 8 is the sum of the previous two terms. 3 plus 5. 13 is the sum of the previous two terms. 5 plus 8. And finally, 21 is the sum of the previous two terms. 8 and 13. So I hope you understand what is a Fibonacci sequence. So let's keep going here. Let's write some more, and then we will approach the question. So 34, 55. I hope you understand how I'm getting these. I'm just adding the previous two terms. 144, 233, 377, 610. And let's just stop there for now. Okay. Now what are they asking? Well, they're asking basically which one of the 10 digits, 0, 1, all the way up to 9, those are the 10 digits, of course, is last to appear in the units position of a number. So if you have a number, let's say 213, the units position is this number right there. So what we have to do is look at the units position of all the numbers that I just wrote and see which one appears last from 0 to 9. All right, so let's go with that. The first one, well, the units position of 1 is just 1, so let's circle that. The units position of 1 is also 1, but we've already circled a 1. No need to circle it again. The units position of 2 is just 2. And similarly for 3, it's just 3. For 5, it's just 5. For 8, it's just 8. For 13, the units position is 3, but we already have a 3. So we don't need to circle it, because I want to exhaust this list right here. The units position of 21 is 1. We already have a 1. The units position of 34 is 4. That's new. We didn't have a 4 before. The units position of 55 is 5, which we already have. In 89, the units position is a 9. That's new. In 144, it's 4. We already have a 4. In 233, it's 3. We already have a 3. But in 377, we get a 7. That's new. And in 610, we get a 0. So far, I have all the numbers circled except 1 from this. I have a 0, 1, 2, 3, 4, 5. No 6, 7, 8, 9. So the last to be circled, if I kept going with this Fibonacci sequence, would be a 6, because all the others have been circled so far. So the answer to number 4 is C. Let the absolute value of x minus 2 is equal to p, where x is less than 2, then x minus p is. Well, if you're not familiar with this symbol or symbols, it means absolute value. And essentially what that means is the distance on the number line from that number to 0. So for example, if x was 5, the absolute value of 5 is the distance from 5 to 0. Well, it's 5. But what if you had negative 5? The distance, the positive distance from negative 5 to 0 is 5. So that's essentially all absolute value means. So they're saying that x minus 2, the absolute value, is equal to p, and they've given you a condition that x has to be less than 2. Then what is x minus p going to be equal to? And they've given you 5 answer choices. So the simplest way, in my opinion, to do this is just give some number values. Otherwise, it becomes kind of abstract. So I'm just going to let x equal, well, let's just equal negative 5, right? Why not? It meets our condition. It's less than 2. You can use any number that makes you feel comfortable. So let's first start with what they've given us, which is x minus 2 absolute value is equal to p. I set x equal to negative 5, so negative 5 minus 2 is p, and therefore p is the absolute value of negative 7, and p is therefore 7. All right, so that's the first part. Now, we turn our attention to the second part, which is x minus p. In our example, we have minus 5 for x, and p is 7, so therefore x minus p is negative 12. Now I have to see which one of these answer choices is going to give me negative 12. All right, let's go through this. Negative 2, well, obviously not. B is 2, that doesn't match. How about 2 minus 2p? All right, 2 minus 2p. P is 7, so that becomes 2 minus 14, which is negative 12. All right, that's good. I'm going to check that for now, but we got to check the choices D and E just to make sure that we don't get two answers or I've done something wrong. How about 2p minus 2, which is choice D? 2p minus 2, p is 7, so that becomes 14 minus 2, which is 12. That is wrong. That doesn't match our negative 12 value. And finally, the absolute value of 2p minus 2, well, p is 7, so this becomes 14 minus 2, and that looks like the absolute value of 12, which is just 12. So that doesn't match our negative 12. So by process of elimination, the answer to number 5 is C. Two different prime numbers between 4 and 18 are chosen when their sum is subtracted from their product. Which of the following number could be obtained? All right, so we've got numbers 4, 5, all the way up to 18. Now we have to choose numbers between 4 and 18, right? Not including 4 and 18. And we have to choose prime numbers. So let's circle our prime numbers. 5, 7, 11, 13, and 17. Those are our prime numbers. Now what are they saying? You choose 2, and then the sum of those 2 is subtracted from the product. So if you have 2, you take their sum, and you subtract that from the product, like that. And then they're saying which of these answer choices could you get? All right, let's work with this here. Let's try 5 and 7, see what happens. We'd have 5 times 7, subtract from that 5 plus 7. So this looks like 35 minus 12, and that's 23. Is that one of the answer choices? No. All right, we got to go to the next one. 7 and 11. 7 times 11 minus 7 plus 11. And that looks like 77 minus 18, and that is 69. Is that one of the answer choices? No. All right, got to keep going. 11 and 13. 11 times 13 minus 11 plus 13. And that looks like 143 minus 24. And that is equal to 119. Is this one? Yes, it is. 6C. All right. So the answer to number 6 is C, 119. How many positive integers b have the property that log 729 to the base b is a positive integer? Okay, so log of 729 to the base b is some positive integer. All right, so let that positive integer equal n. Right, and then we have to figure out how many such values of b would give us n to be a positive integer. All right, so b to the power of n equals 729. That's basically what log means. And 729 is 3 to the power of 6. I don't know if that helps us or not. But let's move forward. Let's make a table. N and B, and let's see what we get. Let's start filling in that table. And let's start with n equals 1. That's the lowest integer, lowest positive integer, I should say. So if n is 1, what do we get? We get b to the power of 1 is equal to 729, like that. So what is b? Well, b obviously is 729. So that gives us one such b. So that works. Next, let's say b is, n is 2. Therefore, we have b to the power of 2 is equal to 729. If this is the scenario, can b become an integer? Well, it can. If you take the square root of 729, it's 27. So this works. So now we have two values for b. So we can eliminate a and b because we have at least two. So how about n equal to 3? Well, therefore, that would be b to the power of 3 is 729. Can you take the cube root of 729, therefore giving you an integer? And the answer is yes, you can. The cube root of 729 is 9. So now we have one more. Get rid of c. How about if n is 4? That would mean b to the power of 4 is 729. Like that. B squared would then become the square root of this, which is 27. And then b would therefore be the square root of 27, and that is not an integer. It's 5 point something. So this would give you square root of 27, so this is not an integer solution for b. Keep going. If n is 5, that means b to the 5 is 729. And if you take the fifth root of 729, it's not going to give you an integer. It'll be probably 3 point something, 3.7 or whatever. But it's not an integer. It's certainly not 4, and it's not 3. So that's wrong. Or that's not a possible integer. How about n equals 6? B to the 6 is 729. And yes, because look, I wrote it up there, so I did actually need to use it. It basically means that b to the 6 is 3 to the 6, so b is 3. And now we've got 1, 2, 3, 4. All right. That's it. They don't have anything greater than 4. So, but just to be complete, b has to be an integer, right? And the only integers left are 2 and 1. If b is 1, you'd have 1 to the power of n equal to 729, and that's impossible, right? Nothing, that would never work. N cannot be made in any way to make this equal. So that doesn't work. And if you have b equal to 2, you'd have 2 to the power of n is equal to 729, and no power of 2 equals 729. So those are not proper solutions. So the only ones for b are 729, 27, 9, and 3. So there's 4 possibilities. So the answer for number 7 is 4, which is choice E. In figures 0, 1, 2, and 3, you have shapes consisting of 1, 5, 13, and 25 non-overlapping unit squares, respectively. If the pattern were continued, how many non-overlapping unit squares would be there in figure 100? Okay, so I believe this is going to be one of those questions that looks for a pattern. So let's see if we can find a pattern. First, let's start with figure 0, and I'm going to, what should I label here? Well, in figure 0, there's nothing to label except this one little square. So we got 1. Figure 1, however, you've got 1 here. Sorry, you have 3 there. 3 squares in that row, that middle row. And then the top row has 1 and then 1 like that. In figure 2, the middle row has 5 squares. It's hard to draw 5 that small. Then you have 3 up here. And looks like you've got 1 there. So 3 and 1. That's the pattern there. And in figure 3, it looks like 7, 5, 3, 1, 5, 3, 1, like that. So just from those 4 shapes, I'm under the impression that 1, 3, 5, 7, the next one is going to have 9 as the number of squares in that middle row. And if you keep going upward in this direction, it'll be 7, 5, 3, 1, like that. 7, 5, 3, 1, as the number of squares in each of the rows going upwards and going down. All right, so I hope that makes sense. So this is figure 4. I didn't draw out figure 4, but you get the point. So now, is there any kind of a relationship or pattern here between the figure number and the number of squares in that middle row? 0 means 1. 1 means 3. Figure 2 means 5. Figure 3 means 7. And figure 4 means 9. I think so. Figure n would basically mean 2n plus 1. I think that would do it. Unit squares in the middle row. Squares in middle row. And I think that is how we're going to do this. All right, great, perfect. So let's go with that. So that means they're asking us for what? Figure 100, right? Figure 100. All right, so that means that figure 100 would have 2n plus 1. So 2 times 100 plus 1, which is 201 squares in that middle row. All right? So I hope that makes sense. So that basically means that if you have 2001 and you keep going up, it'd be 199 in the row right above it, 199 squares in the row right above it, then 197, all the way 195, all the way ... till you get to that final one little square at the very top. And similarly, in the bottom rows, meaning the rows below the middle row, it'll be the same story. 199, 197 squares, 195 squares, all the way down to 1. So I'm certainly not going to draw this. I don't think anybody could. So we have to now add up how many squares we have, because I think that's what they're asking, right? How many squares would be in figure 100? Okay. So I have to add up 1 plus 3 plus 5 plus 7 ... all the way to 195, 197, 199, like that. And then I've got to do it again here. So the first one was here. 1 plus 3 plus 5 plus 7 ... 195 plus 197 plus 199. And then I've got one lone 2001 that I must not forget to add. Okay? And if I add all these up, I'll get the total number of squares in my shape, figure 100. Okay, well, any quick way of doing this instead of manually typing in these numbers? I think so. I'm going to go with pairs. 1 and 199 is 200. 3 and 197 is also 200. 5 and 195 is also 200. So each of these pairs is equal to 200. But how many pairs do we have? Well, from 1 to 199, we have every other number. So we have 100 numbers. We have basically all the odd numbers from 1 to 199. So we have 100 numbers. So how many pairs do we have? We have 50 pairs. So each pair is equal to 200. So to get the total sum, you multiply that by 50 pairs. And then similarly, the second row, I just did the first row. Now the second row is exactly the same. So 200 times 50. And then this lone 2001 that I must not forget to add. So 200 times 50 is equal to 10,000 plus 10,000. And then I've got the lone 2001. and therefore this is all equal to 20,201. 2021. All right, so let's see, is that one of the answers? It is. 8 is therefore C. Mrs. Walter gave an exam in a mathematics class of 5 students. She entered the scores in random order into a spreadsheet, which recalculated the class average after each score was entered. Mrs. Walter noticed that after each score was entered, the average was always an integer. The scores listed in ascending order were 71, 76, 80, 82, and 91. What was the last scores Mrs. Walter entered? So let's say the scores are A, B, C, D, and E. What's happening in this question? First, she enters the first score, and the average is going to be some integer. Well, the first one is pretty obvious, right? Because of course it's going to be an integer. Then she enters another score, and the average of these is also an integer. And then she enters the third score, and the average also is an integer. And then finally, she enters the fourth score and the fifth score. And when she does this, she notices that every time she enters a score, the average of the scores is an integer. So what they're asking for is, what is the last one that she entered? What is E? E representing the last score. But they've told you all the scores, but we don't know which order. So we can just go with the information they've given us. If the scores are 71, 76, 80, 82, and 91, then the average would be all of those added divided by 5. And this is a nice number, 400 divided by 5, therefore 80. So we know that this number right here is 80. All right? Because it's basically representing this average of all of them. Now what we have to figure out is, what is E? Well, how do we do that? Basically what that would mean is that if you take the sum, which was 400, and subtract E and divide by 4, this scenario right here, it would be an integer. So in your mind, you have to figure out, how do you make this an integer? Well, this numerator has to be divisible by 4. And how do we get that? If E is equal to, they even given you 5 possible choices. E has to be 80. If E is 80, this would become 400 minus 80 divided by 4, which is 320 divided by 4, which is 80. And therefore, this would become an 80. So the answer to number 9 is C. The point 1, 2, 3 is reflected in the xy plane. Then its image Q is rotated by 180 degrees about the x-axis to produce R. And finally, R is translated by 5 units in the positive y direction to produce S. What are the coordinates of S? So I hope you all familiar with the XYZ plane. XY, of course, but Z is where you go into 3 dimensions. So let's first label 1, 2, 3. So let's say this is 1, this is, say, 2 up here, and 3, 1, 2, 3, like that. So 1, 2, 3 is approximately here. It's a 3D image, so you're going to have to use a little bit of conceptual visualization. So I hope you kind of see where this is. It was ... 1 on the x-axis, 2 on the y-axis, and then I had to put it 3 on the z-axis. All right? So I hope you kind of understand where that is. Now I'm going to do what next? This image is therefore first reflected in the XY plane. So this is the XY plane right here. This is X, this is Y. You're going to reflect it just like you would reflect it in a mirror. So it's going to go back behind the XY plane. So all the way back, let's say that way. So the X coordinates and the Y coordinates don't change, but because you pushed it back, the Z coordinate becomes -3 like that. And they're saying that this is Q. Right? So I hope you're following me there. Now, this Q is rotated by 180 degrees about the x-axis. So what does that mean? It's rotated around the x-axis. So you're basically rotating it around. Do you see what I mean? Like you're going all the way around that x-axis. But all the way around will be 360, but you're only doing half of that. So basically what that means is that the x-coordinate does not change. You're fixed at the x-coordinate, but you're coming around the x-axis, and therefore the y and the z coordinates will change. So Q, which is 1, 2, and -3, when you rotate it by 180 degrees about the x-axis, the x-coordinate does not change, but then the y-coordinates will, because now you're coming over to the other side, and therefore the y-coordinate would become -2, and the z-coordinate would become 3. So let's draw that on our graph. 1 minus 2 so this is -2, and then 3 plus 3, so approximately here. So 1 minus 2 down to here, and then we've got to go 3 in this direction. So it's approximately there. This is our R right here. So we went from Q to R, so we essentially had to rotate 180 degrees about the x-axis in order to, we had to go basically flipped around the x-axis like that. Okay? Basically if you were throwing like a yo-yo around. And then finally the last one, translated 5 units in the positive y direction. That just means you're going up 5 for the y coordinate. So x stays the same, you go up 5, so add 5 to the y coordinate, so that becomes 3, and then the z coordinate stays the same. So finally our answer is 1, 3, 3. The hardest one in this question, I think, was this one, when you rotated about the x-axis by 180 degrees. That's conceptually the more challenging one to understand, in my opinion. So the answer to number 10 is E.